Yeah, so I would like to ask first, to gather around here and ask Docker team and Groq team to present their demos. We are also live streaming online, so yeah, get ready. And yeah, I will wait like 1-2 minutes, and then we will have the Docker demo. Just to recap, we have submission deadlines at 5:30 p.m. for the offline track, so I hope you are in the middle of building. Feel free to ask more questions, and after 5, please submit the solutions in the Shipyard platform. Feel free to ask more questions, grab lunch, ask if you need anything. Let's wait a bit for coming. Okay, I think you can actually start.
Hey everybody, thank you for showing up today here at this awesome hackathon that we've got going on, and thank you to E2B for making this possible. This is awesome. We've got a great venue, we've got lunch in the back. Really appreciate the offering here. So my name is John, I'm from Docker, and I want to show you a little bit about what we've been up to at Docker. You probably are familiar with the brand name of Docker. We've been around for a long time, have been kind of doing the same thing for the last 5 or 7 years. It seems maybe it's been lacking a little bit in innovation, but we earlier this year we got a new CEO, and ever since then, we've been hard charging on AI. Obviously, everyone's working on AI now, but we've done a lot over the last 8 or 9 months with AI, and specifically today, we're going to talk about MCP. And as I'm sure many of you know, one of the challenges with MCP is it makes all these assumptions about the software that you already have installed on your computer. If you want to run an MCP server, like you need to have Node installed or Python or what have you. So it makes perfect sense to containerize your MCP servers, and that's what we've done. We've taken 200 or more MCP servers, containerized them, and made them available on Docker Hub. So you can pull MCP servers from this large catalog at Docker. It's not just container images anymore, it's MCP servers. It's also large language models that are open source. But as part of what you're working on today is leveraging MCP servers, that we now have a partnership and integration with E2B, where if you run a sandbox, you have access to all these MCP servers in the cloud, which is super, super cool. So what we're gonna take a look at today is just a very simple integration. Very simple demo. Let me make this a little bit bigger, but I'll walk through the code really quickly, and then we'll do the demo, and then can ask questions if you've got any questions. Pretty simple. We're gonna stand up a sandbox, but in the sandbox we're gonna make available these MCP servers. And this is all done behind the scenes with some magic that E2B did for us. We also are, a few months ago, we built this thing at Docker called the MCP Gateway, which acts as a proxy for your applications to send all their traffic through to MCP servers. So we're leveraging the MCP Gateway here as well, and getting some credentials essentially to have the sandbox talk to the MCP Gateway, which will then talk to the MCP servers. So let's just go ahead and live dangerously here, and let me pull up my terminal. Make this a little bit bigger. All right, so we're going to run a very simple script. It's going to spin up a sandbox using the SDK and take advantage of some MCP servers. One thing I did earlier that I thought was pretty cool is I kicked this thing off and quickly switched over to our dashboard. And having trouble reading this time, but I have to assume that this is not lying to us and that this is actually real. And my script will finish very quickly. It's running. Right now it's calling the Notion MCP server and the GitHub MCP server. And it's going to create an issue in my GitHub repository. All right, it finished. So let's switch back over here and see how long the sandbox lives. So the sandbox spins up really fast, right? That's great. And look, it's already gone. It's the beauty of ephemeral environments. We spun it up, we ran whatever we needed to run, and it disappears and doesn't continue running and racking up our cloud bill. And then if we come back over here, this is the GitHub repository. Here is, oh look, I did it twice. But this is the issue that we just created. Yeah, so again, take advantage of all these MCP servers. The other thing to take advantage of is the gateway. And this is, it's open source here. And in fact, if we come back over to the terminal, we can see where it's actually going to spin up the MCP gateway here and make this available. Anyway, I think that's a wrap. Hope you enjoyed it. If you've got any questions, thank you. If you have any questions, come find me afterwards. I'll be here all afternoon. We can talk more about this. Yeah. Thank you.
There's no sound. Cool. This is the end. Hey everyone, my name is Jan and I work with Groq as a developer relations engineer. And I'm just going to go through this very quickly, but with Groq, we're an inference provider. We're kind of like OpenAI or Anthropic, but we provide open source models and they're very, very fast. And the reason they're fast is because we have our own chips, we have our own data centers. Every month or so we launch another data center. This past weekend we just launched a new data center, a 1 megawatt data center in Sydney. And so that just came online. And every couple of weeks we just add more and more data centers. I made this like a few weeks ago, it doesn't even have Sydney. So we're growing our capacity every couple of weeks. So just very quickly, with Groq, we're adding a lot of API endpoints that are not exactly models right now. They're more like agentic systems. So what we call it Compound. And it actually uses E2B under the hood. And basically, if you use, when you send a request to Groq, you replace the model name with Groq/compound or Groq/compound mini. It can actually run code like with one API call. So if you say like count the number of R's in strawberry, use Python. We have an agentic loop that spins up an E2B sandbox, runs the code, counts it, and then returns back the results. And again, you can do that in a single API call. It's very easy. And same thing for agentic web search. So if you're building like a deep research tool, or if you need any kind of web search in your in whatever you're building, again, you don't have to go to like Excel or Tably or all these other places to grab your own API keys. We're essentially a middleman to some of these services. So all you have to do is switch to Groq/compound and just enable the, it'll all be enabled. Like web search will be enabled as part of that system. So again, if you want to look at that, scan the QR code. And again, we have a $10 coupon right now, so if you guys want to use it, it's all over here. We have a $10 credit for dev account, and that's it. I'm going to show what you guys can build on Groq. I'm sure you guys are familiar with this already, but E2B has these really good documentation under MCPs to get started. And so this is something I used to build my demos. So this is the Groq with Exa MCP example. And what it does is it essentially, again, this is the code that I didn't write, but essentially it spins up a sandbox with the Docker MCPs. And then with Groq, we have this thing that can connect to any remote MCP server, which means that if you have like a hosted MCP server, we can connect to it by treating it as a tool. And so this is something we've been spending a lot of time on to make it work really well. But basically with E2B, you can spin up a sandbox for any MCP server, like run it as a remote MCP. And then for us, if you want to use Groq and agentically use a Groq model to talk to the MCP server, you would essentially just plug in the server URL. So you can do this manually, or you can just read the sandbox MCP URL and feed that into the Groq API call, and it'll just work. So you can do this with anything. So earlier, I vibe coded this tool. The design is done using Gemini 3 Pro, which is incredible. Like one-shotted all of this pretty much. And so I can do login. I created my own MCP vibes app in GCP to make login work. And again, this is like 10, 15 lines of code, and most of it's like CSS and Tailwind. And so this uses the setup I just showed you to read my emails and read my Google Drive, and then I can chat with anything. So if I just click on, well, apparently I don't have events today. Yeah, this is my personal calendar. But yeah, so again, this took, oh, nope, that's my actual email. Okay, so again, this took like 20 minutes to one-shot generate. And so you just basically feed this demo into Cursor, and like in 20 minutes, you can build something like this, and then ask Gemini to make it nicer, and like in 30 minutes, you have this. You can literally build your own Google dashboard in 30 minutes using Groq and E2B MCPs. Yeah, that's it. Yeah, any questions? No. Well, thanks everyone.
Okay. one, right? Okay, and now we announce the online winners. Thanks, Docker and Groq, for the demos, by the way. Okay. So let's see. We had 36 submissions for the online round. So first, I will do a quick overview. Later, we make them public, so you can also check in the shipyard what people build as an inspiration. There was like a big diversity of projects. You can see a lot of them was some education topic, testing code, debugging, searching something. So it was really like high variety. And it was difficult to choose the top 3, but thanks to our judges, like we spent some more time on that and choose top 3 winners. So I will start with the 3rd place. And 3rd place is this project called Lowballer AI Real Estate Negotiator. It's project by someone with nickname Arun. And yeah, I will show the demo. Probably this is the live demo. It's basically exploring some like risky factors about real estate, and it's trying to negotiate lower price based on the information it finds. The author called it dirt. So I start investigation here, and while this is running, I will also play the demo. Oh, okay. I can't. What? Yeah? Okay, let me. This demo is without sound, I think. But hopefully you see it. Okay. Oh, it's just recording. Okay. So it searches the property, and it will use the MCP, I think, from EXA to scrape information from online about the property. Let's see. Now it's configuring the Docker, connecting the sandbox and the EXA MCP. Yeah, and it's even generating the negotiation that is later sent to probably the property owner, from my understanding. Yeah. Okay, let's wait. Okay, so here we can see the result. So it found some information, evidence, probably some sketchy things about the real estate, some information that can help negotiate, and it created the email. You can see the logs there also, how it's connected to the EXA web search. For those who don't know, EXA is a web scraping service. It can like search the whole web and put together information from different sources based on prompt. Yeah, and here we have the evidence and the email. Yeah, so I think judges selected this because it's also usable in real life. It has some business value. It has nice demo and functioning code. So we liked this submission overall. So this is the 3rd place for the online track. Congratulations, if you're watching the stream. Okay, now we go to 2nd place. And 2nd place was assigned to auto MCPs. So let's again play the demo. This time I think it's with live comment.
And I'm working on auto MCP. I let you generate MCP servers from the API documentation. I'm also using the batch MCP server through Docker and Groq to power the AI loop, E2B for the main sandboxing. So I'm going to show you guys how it works. I tried to generate a MCP server using an actual documentation of the JSON placeholder. It's a real service, real APIs, but it's meant for testing. And so we can see how like it starts to grab the documentation, and then the main agentic loop goes really fast because of Groq, and it's just And during the execution in the sandboxing, it's just, I guess it's running into failures and trying to make patches, and it tries to runs it again. But then finally gives up because it reached the end of the max attempts. And then it goes on to say, hey, we're going to give up, but you can download the files. So we're going to try to do that, open it, and boom, server's here.
Okay, so this was second place. This is like auto generation of MCP server. We liked it for its originality and like innovative factor. Like I never seen a project similar to this, so I thought that's pretty cool. So second place goes to, okay, Bin Bin He. Not sure if it's his real name, but we will find out. So congratulations to that. And first place goes to project named Patched Pilot. Patch Pilot is a debugging agent that uses E2B sandbox and again Exa MCP. It generates a patch, it validates it, runs tests, and opens pull request with GitHub MCP. So it uses multiple MCPs. Again, I will run the demo for you to check.
Directly.
Okay.
Okay, now introduce Patch Pilot. It's an autonomous bug fixing AI agent, or I would like to say it as an engineer. So let's directly come to the demo. All it needs is first the repository URL and which branch it is, also the description of the problem or the GitHub issue. I will use an open source for this demo. Okay, I'll choose this one for Next.js and I have like put it in my local branch. Just fork it. And it should be the canary branch. And the issue, I'd like to paste the exact one from the original branch. The test command supported by this repo is npm test, and currently I will skip the test for now. And as it starts debugging, we will have a progress bar, which shows, okay, which current stage we have. It has like several steps for this agent, total in 8 steps. First, it clone and install packages. Install all the needed packages in the sandbox. We use the EB2 sandbox. And next step is to analyze the fields. Patch Pilot does not read the whole project. It does do the analysis for which fields is needed based on structure and the description of the issue. And then there will be a real-world fix pattern. We use the Exa API for this in the sandbox because Exa is good at searching all context and avoid the AI hallucination, which could give us a solid result. And yeah, we also have AI-powered patch generation using Groq LLM, and it summarizes the root cause based on code analysis and extra patterns. Also, it explains and changes human readable terms, and also supports multiple response formats for maximum flexibility. Then for now, it's come to the patch session. And currently we skip the test session and will add it on by just uncheck the checkbox before leaving home page. And at last, we will create real-world pull request. And I'm using the GitHub API in this case. Okay, here's the logs we have for each sections, which what we are solving and what content Exa searched. And we found several relevant fields to this problem or this issue to let the LM or our agent to look through. And then they found the root cause and it creates a pull request. We need to manually click it. It does not directly do it because it avoids some security issue. So when I click create pull request, Yeah, it's creating it, and it takes a while. Okay. And in this project, I use a real-time, like real-world fix retrieval using Excel. Also, the fast AI I'm running for Groq. And then the safe and reproducible execution, E2B, in the sandbox and execute everything in the sandbox. And I also use a real pull request via GitHub MCP. Also in the front end for the Next.js and Prisma plus SQLite for database. And for this one. Yeah, we can see the branch comparison for the pull request. And we can check each session it detects, and it's human readable, and we can check it manually before we actually click pull request. Only one button remains for us. And yes, this is Patch Poly. And if we want, we can view all the sessions for all our tasks. Yeah, I have a lot of field because previously I made some mistakes for the AI prompt, but I revised it. If we can see something like the field, it will contain exact message of why it failed and in which step it fails. And yeah, basically this is Patch Poly. It's AI autonomous bug fixing agent. And hope you like it. Thanks for listening.
Okay, so this was quite complex, including the code, so that's why we liked it, and that's why we chose it for the first place. So congrats to Zhang Luxin. So this is winning the first place, and yeah, thank you everyone from the online track for submitting amazing solutions. It was very difficult. We will make them now public, and we will also reach out to everyone to also promote the solutions, share the projects, and give some recognition, because a lot of them were like very good quality. So yeah, congratulations to the online winners. The offline track still continues until 5:30 p.m. Here in San Francisco. Judges are on the spot. Feel free to ask any questions. Dinner will arrive also on evening. So yeah, reach out if you have anything. Now we are stopping the stream for until I think 7 p.m. when we start the final round here offline. So thanks. That's it for now. Okay. ready? But MCP? No. Is any of the finalists ready? No, okay. So we will wait a few more minutes. MC Pilot, okay, so you can get ready here and present. So we will have MC Pilot. Connect this.
Yeah. Nope, no sound, yes. Okay. Yes. So yeah. So hi judges. Have I never made this problem before? We have more than 300 MCPs right here on the platform. But I want to build a workflow. So which MCP should I use? How could I connect them together? I need to click into each and read documentation, read for API keys, connect all that. And it's consuming time. What we do right here is we do augmentations. It's an AI-powered orchestration for MCP. We first do the capability analysis, and then we do the smart matching. We can using algorithm to rank more than, right now we're supporting 147 MCP service right here. Then we do code generations. Then we help you to deploy the overall workflow on E2B. And then we can do some lab verifications right here. It's kind of build up your own workflow just through a word. Let my teammates to do more show on here.
So our app will start from taking a user input, describing what the task result they want. So for example, if I want an automated flow that monitors failed actions on GitHub, searches the web for the solutions, and then sends the Slack alert to me with error details. Then running this app will give you a multi-agent system structure and explaining the workflow to you and give you the executable code integration snippet and execution results. So the first step of our app is to analyze the compatibility. So for example, to do the task above, the first step will be determining like what MCP servers to use. For example, to deploy, to detect failed actions on GitHub, we need GitHub official MCP, and then to send error messages on Slack, we need Slack MCP servers. So basically, our app will help you decide what MCP could help to complete your task. Second, we give you a cost analysis. So for example, using the 3 MCPs, actually 5 MCP servers above will give you a fixed cost of 0.2 cent per run, and for a month that will cost you 6 cents. This is the fixed cost, and the flexible cost depends on your API usage, so it's not listed here. Here we tell you the reasoning behind using these SCPs. And also we give you environment setup, like how could you set up your Docker container to use these MCP servers, and we give you a code example of how to integrate use MCP servers into your agent system.
Okay, you have last 30 seconds.
Okay, I'll be really quick. Then we show you a mermaid diagram to explain the workflow to you, like how can you connect these MCP servers together, and then we run the deployment for you. So we have like the result of running GitHub MCP server, and this is and we have an analysis result. So yeah, basically it's from an idea to deployment, and everything is automated for MCP integration.
Thank you. Any questions from the audience, from the judges? No questions? Any questions?
Pardon? Is your latest code uploaded? Yes, yes.
Any questions?
Any question from judges and?
What would you do next with the project to make it more production ready?
So the first thing will be to get more data sources. So currently we have like about 140 MCP servers in our database. All of them are from the Docker's MCP server hub. Next step will be add MCP servers from other platforms and make their data format compatible with each other. So for example, some containerized MCP server on other platform might have different format than the containerized MCP server on Docker's hub. So expanding the data sources would be the first option.
Yeah, and then we could, in the code generation part right now is pretty poor. We plan to use cloud for the code generation part. So we really have an agent right here behind the code run the generation part and use the multi-agent system to define, okay, our code is really could work on that case. And also when we run this, we want the code to be really productionable. Right now we help to deploy on E2B, but in the future we might deploy it on other platform. We can let you choose AWS, Azure, GCP, whatever platform you want. We'll help you do that and we'll give you back your URL. You just call this URL, we will do everything you want. It's kind of like the next step, but right now the code is only generally we use Llama, so Llama 4 is not that power. It sometimes makes some mistakes. Yeah.
Okay, thank you. Any other questions? I think we don't even have time. Okay, so thank you, team. That was the MC pilot. And now speech to spec. Are you ready? Okay, so speech to spec is presenting second. Please, judges, also assign your points in the platform. And now speech to spec is getting ready. So you have 3 minutes demo, 2 minutes questions.
Could you bring him this, bro? Careful. HDMI? Yes. I could do like this. HDMI? Yeah, you can. Use this if you want. Okay.
Could you take the phone from my pocket? Tell someone to record.
Supposed to show something right now?
So the sound is coming from the computer or from this?
From the computer. Supposed to show there?
Wait. It's gonna
Okay.
happen. It's
Wait, why it looks like that?
you need to change the resolution on your computer.
Oh, I think that's enough.
That works. Are you sure?
Yeah.
It might screw up the React components. No, it's fine.
Let's stream computer. Stream.
We can just change the resolution on your computer if you want.
do that.
No, but it's complicated. If you can do it with your laptop. One more.
The resolution. Oh, it's working.
Hey, can you hear me? Can you hear me? Hey. The AI, yeah. Hey, AI, can you hear us? Hey, can you hear me? Yeah, it's hearing us, but it's not streaming the audio. So let's do it with this. Sorry. Can you hear me? I need to reload the screen real quick. Yeah. The thing is that this is an Arch Linux computer, so it's kind of... yeah. Yeah, they use the audio to... You can't hear.
Can you just make it mirror?
That's what I was supposed to change to share your laptop, bro. Okay.
Okay, it's working.
Can you hear me? Hi, can you hear me? Okay, yeah, sorry. Hey, can you hear me? Can you hear me? But basically, if you wanna, looks like the audio is not working. It's not. I think it's like seeing us. So I wanna build a cool app, you know. So what we basically do is like we jailbreak the Ray-Ban Meta classes, and we find a way to get access to the camera, and make something called speech to spec. So basically, it's a middleware between the user and the coding agent that is being running on E2B. So how it works? We use using our camera, we can actually use it with voice to do something for us, to build any app, or we can actually draw it right now, you know? So we can actually say that, please build a co-founder match app, you know? And it's going to build it for us. No, the stream is...
Should we just cut the stream and do it on your computer? Like,
and then we
yeah.
can
Show the computer. Like,
You had the video that we got it working?
just run it on your computer and then we can flip the screen around. Sorry.
No, I think like it's gonna. And what you're seeing right now, this is what I see inside the glasses. So if this demo is working live, I could actually draw something, and it's going to build the app in real time for me. If I can say, oh, please change this, you know, it's going to change it in real time. Using Groq with Kimi K2, this helps us to iterate and update the app really quick.
Andres, just disconnect and do it on your computer. Like, we can just flip it around. That's better than explaining.
It's true. What is still running?
Yeah, disconnect and then do it on the computer. Yeah.
Yeah. I think I'm going to do it with my laptop without stream, so you can hear what is making.
Do you guys want to fix it and let someone else go and do it?
Of course. Why is it not speaking?
Mute yourself after so that like it's not picking up.
Yeah. I think that if we get the opportunity to fix it, we can make it work. Sorry
Okay, so
for
maybe-
making you waste your time, but you know, like even Mark Zuckerberg failed a live demo, you know, so it's kind of
Okay.
complicated.
So, thank you. So, let's present Chaos Lab now. Is Chaos Lab ready to present? Okay. Okay, thank you.
Okay. All right. Hello, everybody. Can you hear me? Okay.
Be a bit louder.
Am I audible? Yep. Okay. So our product is Chaos Lab. It's basically a stress test suite for your apps. It's similar to the idea is inspired from Netflix's Chaos Monkey, where they simulate a random monkey going into a data center, bringing down a bunch of instances. So you try something similar with your offline apps. So as you can see in the interface, you can induce a bunch of network delay. You can max out the RAM, see how the app performs. You can fill up the disk. You get the point. So I'm going to start a run right now and explain on the way. I'm going to do a high-intensity memory pressure test. So what this does is it spins up a bunch of E2B instances, E2B sandboxes, and it tries to max out the memory. It sees how the app performs. It makes a note of the CPU utilization, logs, and all of that. And one interesting thing is, based on the logs and based on the context of your application, we have an LLM that runs on Groq that summarizes the results, gives you recommendations on how to improve. And it also connects to Grafana via an MCP from the Docker Hub, and it gives you a very good, nice little dashboard. So as you can see, my instances are running. I run a bunch of them so that we can average out the values. The RAMs are being maxed out. We already have a run, because since that's going to take a while, I'm going to show you a run that we just did. Which one I said? This one? Yeah. Oh, wait. Okay. Is it Grafana up? Oh. There you go. Okay. Yep, it gives you a very short AI summary. The application demonstrated resilience under memory test, but experienced memory and CPU spikes, obviously. It also gives you some metrics based on the timestamps. It polls each second, each 5 seconds, and you can see all of the metrics here. Also gives you recommendations based on the context of the code base. So it's referencing a specific API and giving you recommendations. So this is basically the product. The future direction of this would be to make it more like feature specific, be able to test one feature at a time, and put it under all of these restrictions. But yes, that's more or less our product, Chaos Labs. We can test your product before you ship them to make sure your product not only runs in something like this, but also something like this.
Okay, thank you. Time's up. Any questions from the judges, from the audience? No questions?
I have a question. What was the hardest part about the project?
Coming up with different tests and how to implement those tests. For example, the memory test and the CPU test, and we got to simulate it using some Linux commands, and we got to actually make it work because the resources were deallocated whenever we try to max out the RAMs and those stuff. So we had to come up with those. Yeah. Thank you.
Okay, thank you. Any other questions, or we go to next round? Oh, one question.
If you have more time, what else would you add to it?
Yeah, like as I said, first things first. When you have an app, you don't always want to test the entire app, right? Because we had a pretty simple Flask app, we were able to do that. But we're looking to add per feature tests. Like you pick one feature and see how that specific feature performs under a memory load or when the disk is full. That is one direction you can go in. We can also work on generating better context from the code base, because if the code base is really big, then it's pretty difficult to give recommendations on how to make the performance better, right? So we need to work on summarizing and compacting the context of the whole code base. Those are two things I think we should work on if we productionize this. Thank you.
Okay, thank you very much. So that was Chaos Lab. And now we have BET MCP. Thank you. Is BET MCP ready? Yeah, I see you. Okay, you have 3 minutes demo, 2 minutes questions again.
Okay, so imagine you're a betting addict and you spend hundreds over hundreds to try to recover your losses. This might not be very common in the US since sports betting is illegal, but from where I come from, for example, in Italy, 40% of the population betted on something over the last year. So let's say you lost thousands of euros. Let's say you've lost thousands of euros and eventually you want to start getting more rational with your bettings. And you can use BET MCP, which should show up. Okay. You'll find all the upcoming matches from the NFL teams. And by selecting one of the upcoming matches, you're able to get a prediction, which is generated by a Brave MCP server that gets all the info from the teams which are participating in the match. And essentially, by using E2B instances, we are also able to generate some charts. Complete report is generated. We will see it now. It takes a bit since it's a mix of multiple stuff generating in the background here. And yeah, essentially, if you want to bet, you get something more scientific and some data, which is current and allows you to make more rational decisions. Let's hope it doesn't take, okay, yeah. So essentially you just get this complete report, you get all the the points, the percentages over which you're likely or unlikely to win. And then this is for an example chart generated by Python in the E2B instance to show you the odds. Okay.
Okay, thank you. Any questions to this team?
Yep. I mean, you can see later, you can read it better. Yeah. I don't know, millions.
Have you actually tried finding out the accuracy of the insert data?
No. This is like not betting advice, so it's not it's not made for taking actual decisions. It's just to give some tips. But no, we did not evaluate over past data. This could be cool, one of the future steps. Yep.
There's no heuristic, no probabilistic, deterministic model, no regression, nothing. Just spitting out some rubbish.
Well, spitting up-to-date facts, it's something, I guess. But yeah, see it.
As we are running the code in the background on E2B, so we made some analysis with that code. So it's not basically LLM. So we have these, the part of the text and the charts here, it is made with code. So this is why it is more relevant than just LLM generate text.
It's like a semi-enforced JSON schema with data from multiple,
Gotcha. Okay. I understand. You're front-loading, back-loading the prompt with as much real-time data as you got.
Yeah. As long as it's useful for the user, yeah.
Well, let me ask a more validating question. Would you make a bet right now based on
I would, for sure, yeah. I just can't. I have 2 minutes, Okay.
What kind of data do you have with time in the context? Because I could see that there's some wind is there.
Yeah. I mean, as I said, it's a semi-enforced schema, so it's not mandatory to have some types of data over others. But as I said, an example could be an injured player on a team, or as you saw, wind, whatever, streak of past losses, change of the trainer in the team.
Where do you source the data?
From the web search. So it's not from like specific APIs or stuff that is static, but it's what comes up from the search, essentially from Brave browser. Okay.
Okay, thank you.
Thank you.
That was cool. Thanks a lot. So that was MCP bet, and now, bet MCP, sorry. And now patterns with code, get ready to present. Patterns with code. So we have two more teams to present. Patterns with code and then speech to spec. Okay.
No, there's no sound.
Okay. It's not working.
Should I select this? Yeah. Entire screen? Start new line? Oh, that worked. Okay, great. Okay. This is very hard to read, is it? Okay, it's okay. I hope the demo will work. We are pattern with code. So our inspiration is when you read papers, you really want to see after reading the paper, you want to see what the code look like. And a lot of papers do that. But when you read patent is very notoriously hard to read. There's a lot of very hard to read plots and even more text that you don't know what it is about. So in this presentation, we want to start with visualizing the software pattern. We want to know what this complicated document is talking about. So what we start with is a search engine. So what we want to do is, let's say, we want to know if there's any pattern related to double tapping. So we just search double tap, and then we will start our MCP servers to using XHAT to do the search on related patterns related to double tapping. And then once we find some of the patterns that we are interested in, we start to crawl it. And we specifically ask to use MCP to crawl this pattern to the text format instead of the original PDF document like this one, is because we want to do interactive demos. Like we say, this is a very hard to read document. To actually reading this kind of document is not easy to understand what you're talking about. So we want to give this complicated pattern text to LLM to see, oh, can you just help us to implement it to give us a spec? After we have the spec, it's much easier to understand, but even better is, can you generate code to just show us exactly what this means? So what will happen next is a cloud code sandbox will be started, and takes that specs and trying to generate the code that is specifically mentioned by this pattern. And then we can even see what this code is in a very safe sandbox environment. So here, this pattern is actually very simple. It is just double click to zoom in. So this will make it much easier to read this very complicated text that is talking about what this pattern actually is. And we also do some very complicated thing. The most challenging part of this project is, of course, the code generation part. So we really want to make this example work, which is the pattern that for a swipe gesture on the touch screen for a like or dislike. But it doesn't work always, so I'll just show the demo. So it was able to generate a very nice swipe demo that is based on the pattern text itself. But if I do it one more time, it's probably not going to work. But yeah, that is the most challenging part, because the coding agent sometimes works, sometimes doesn't. It's really depending on the quality of the specs and the quality, I guess, some randomness on the translating the spec into the code. Yes, that is my demo.
Okay, thank you a lot. Are there any questions?
Are you not worried about losing fidelity from the very complex pattern text into the specs and further on into the code implementation?
I think it is more of a research tool to quickly understand what this pattern is about, before we dive deep into the nitty-gritties. One thing we actually wanted to do, if you have more time, is right now we're only visualizing the software pattern, but if you think we have a hardware pattern, it's even harder to read. But if you can render it as a 3D visualization, it will be much easier to see what this specific pattern people are talking about. So I think the perception we want is, this is a visualized kind of understanding tool. Once you see, oh, this is actually what I want to see how they specifically implement it, maybe you can deep dive into the text. Yes?
In the pattern that you showed, there are a lot of images. Are those used as input when you generate the artifact?
Yes, that is a very good question. So if you send that image to a cloud, it will generate much better, because the image kind of give it a blueprint of how to draw that. So that is the specific example here is visualizing, because Tinder actually put some simple drawing there. But if you don't, what we did just for the speed of the demo, we just put plain text there, and then the generated result is much more plain and, oh, this one is killed, but much more plain and hard to visualize the exact richness of the interface.
So you do extract the images?
Not extract the images, we send the entire PDF over. Yeah, so we can either send the entire PDF over, or we can send the extracted or crawled pattern text over. There's two options, one is slower, one is faster, and the code quality differ a lot.
Okay, any other questions?
If you have more time, what do you do? Or who's it for?
I think it's for people who is researching the pattern, for understanding it very quickly, kind of like doing the top level research. If I have more time, as I said, we would like to work on hardware patterns. For that, we will mostly focusing on visualizing it using some kind of image models to see the specific blueprint that they draw in the pattern, what it looks like if you render it.
Okay. Okay, that's it. Thank you very much for presenting. It was great. And so for the last team we have, I will call the speech to spec that had technical problems. So if you fixed it and are ready, showing yes, okay. So that will be the last final team. I see judges already judging in the platform, so we will know winners after the last demo.
Jag är som går.
Give me a second. Am I? Okay. Yeah.
We're good.
It's okay. Good night, San Francisco. How are you guys doing this night? Are you guys ready to see the last demo of the night?
Yay. Yes. Let's do it.
Feel the energy, you know?
Okay.
Now let's try. Yeah, like, you know, like always live demos is a little bit complicated.
Are you sure we should even connect?
Can we do give me the sound, please?
Sound?
Yes, sir. Okay, the camera is working.
Has to be a mirror function, right?
Okay, let me see the sound.
Okay, you need to change the output.
Yeah. This one? Give me a second. This one, right? Oh, these headphones.
Headphones, yeah.
I think it's not going to work the audio, but we're going to listen with my powerful speakers. Sorry. Okay, yeah, that sounds better. That always work.
Yeah, I can help. I can help. Wait, do the microphone test.
Yeah, wait.
The microphone.
You need to extend your own.
Yeah, give me a second.
There's no audio.
Where is it?
I prepared the build request. Please say yes, or confirm
Where
to
is
start
it?
building. I prepared the build
Where's my
request.
mouse?
Please say yes or confirm to start building.
Okay, I just gonna. Where is this? Why it does not showing? Fuck.
That's interesting. Maybe we should just turn the screen around.
Okay, where is it?
Yeah, you should be.
Where is it?
Yeah. Okay, go in your settings, display.
This is, I get this.
Okay.
I know where it's like the resolution is not good.
Oh dear.
Go in your
They disappear. I think it to show like that.
Just flip it around. It's
Yeah.
fine.
Just go in your settings, display. Okay.
The thing is like this is on a large Linux machine, so I need to install the drivers, configure all this. It's not like the other laptops, but I'm just going to show my screen and show you guys.
Can we flip this around?
Yeah, I'm going to starting this. I started, and then the demo is going to be soon. Okay. Let me do the camera. Turn on the phone, bro.
Okay, time's almost up.
Almost done. How much time we got left? Or that's enough? Yeah. So basically, we find a way to use the Ray-Ban meta glasses to... Hey, how are you? Can you see me? I want to build a co-founder match app. Can you do that for me? Yes, I want to build this co-founder match app.
Say yes or confirm to start building.
Yes.
I've
So-
prepared the build request. Please say yes or confirm to start building.
Yes.
Starting the build now. Got it. Starting the
So basically what is happening right now is a middleware between me and Cloud Code. So there's a voice AI agent that is writing speech to spec to tell Cloud Code to build a real-time app inside the E2B sandbox and using the fastest inference with Groq to get like a almost instantly really cool app related to this thing, you know? So we find a way to get a stream of the video and we just put it here that we need to do something. With some of you, we do the demo on the whiteboard. Like I asked some of you, just please draw an app, and it's going to build it. So then, as you see, it's going to start trying to build the app, and it's going to take a while because. Can you please rerun and fix the query? Can you please try to fix the errors and rebuild the app, please?
I cannot
Come on.
build the app.
And basically it's going to build an app. But the coolest part of all this, like we got access to the camera and this Ray-Ban meta got a display inside. So I can see here live, but you cannot see, but like after the demo, you can show you the Ray-Ban. I have a display here that I can see the actual, like this view, I can see it here and I can see it. Yes, change it, tweak it. I want a bigger text, different color, and all of this, you know? Please build a co-founder match app. Use the guest of the list on Luma, please.
I prepared the build request.
Yes.
Please. Starting the build now.
So this is the second try. Like the problem is like since we are using Cloud Code, we're using a router to use Cloud Code with a KimiK2, and sometimes KimiK2 is a really good model, but sometimes hallucinates running a command that crashes the apps. So like 1 or 2 times actually works and the other ones doesn't work.
Okay, thank you. So time's up to make it fair for other teams. Let's move to questions now.
Yeah.
Thank you.
Thank you so much.
Any questions?
So I have actually seen it work like on the whiteboard. It's
Yeah.
really cool. How did you reverse engineer the glasses to stream the video?
That's a really, really good question. We're engineers and we're hackers, you know? We always find a way. So we actually, like, we didn't find the hack today, but we and our friends, we get this cool pair of Ray-Ban meta glasses, start playing around, and we find a way to get the stream of the video. I put something on the display. But it's not relatable, like, we get our accounts get banned and we need to roll it back and find a new, yeah, you know? So it's not relatable. Okay, like, right now it's building a co-founder matcher thing. It's going to take a while, you know? Yeah.
Did you put the effect test button?
No. Any more questions?
I have a question. So you said you're using Cloud Code to communicate to...
Yes, sir, with Groq.
At what, since the interface you're using, it looks like Gemini's live APIs
Yes.
for base support. I was curious about what is the input to communicate to, because you're live streaming, but
Yeah.
using a model that doesn't support live streaming. So what frames, at what point do you pick?
No, basically, like it's a middleware. So whatever the voice AI agent, like Gemini, is going to tell to Cloud Code, is going to interpret it and tell to Cloud Code. So if, like, for example,
Do
you
you
work.
have another module that's processing? I'm just trying to understand what is the final input and how do you decide? At which frame from the video stream do you decide? Here's the input of...
We're for Gemini Live, we're streaming every single time. Every single second, we're sending the video to to Gemini. And then, yeah.
So actually, Gemini, what it does is interprets our like the voice, and then builds a query, a good query to send it to Cloud Code. So it's not like it's streaming all the time to Cloud Code. We have it to
extract the image from the video frame
yeah.
and the query.
Yeah.
Yeah. Yeah.
Okay, no other questions? Thank you then.
Thank you so much.
Thank you so much. Okay, so thanks all the teams, and I'm leaving judges last few minutes to score, but I already see most scores in the platform, so we will announce the results just in a few minutes.
Yeah, it's all this open source, by the way. Yes. Yeah, but it seems like we need to run the VM and all this, you know. So, yeah, should always service. Thank you so much. Cheers.
Okay, so I think we have the results from judges. I see all judges look like they are in sync. So let's announce the third place. And on the third place, we have the team, let me double check, MC Pilot. Please make some support and congratulations. So please take your diploma. Okay. So congratulations. So you are the third place. Yeah, let me take a photo. Okay, congratulations. Okay. Now on the second place, we have Chaos Lab. Thank you. Chaos Lab, come here. Okay. Yeah. Congratulations. So, Chaos Lab. Okay. And on the first place, after some difficult judging and deciding, it's the team Patterns with Code. Okay, come here. Congratulations. Thank you. This is your diploma. Okay, congrats. Yeah, so that's a wrap up. I wanted to say thank you to everyone. I will contact the winners to choose from the prize pool. So first team picks 4 prizes, second team picks 3 prizes, and third team picks 2 prizes. So I will contact you with the selection. Thanks everyone for great submissions. We will also contact you for any promotion of the submissions we want to support, also online, and give some recognitions from E2B. So thank you again for attending. Hope you enjoyed today. Grab some more food and hope you had fun today. Thank you very much.